Alright, so this is a video about complex or compound fractions. Compound. That's going to be problems like number 14 or number 16 or number 15 in that order. Compound simply means, or compound fraction simply means fractions inside of other fractions. All right, let's look and see what we mean. These are all compound fractions in the sense that you have small fractions, or I would say minor fractions, inside of the larger fraction. You have the orange fraction, the yellow fraction, I said those in reverse order. You have a light green fraction here. That's still not light green. There you go. And then you might have a purple fraction, right? So problem number 14 has 4 different smaller fractions, or maybe minor fractions, in its structure. So you have smaller minor fractions, or smaller fractions, those are all of the interior fractions like yellow, orange, green, and purple. Then you have the major fraction, and that's the entire structure. You can see in problem 16 you have again 4 different fractions using the same color scheme. It doesn't matter what colors we use, just trying to keep the pattern similar, right? Whereas in problem 15 you have only 3 different fractions in this major fraction. You have 2 in the denominator, but only 1 in the numerator. Okay? Also, each of these you'll be asked for the domain. I want to remind you what the domain is. The domain is the restriction based on the fact that the denominators may not equal to 0. Well, that's kind of a simple idea. The issue is, actually I want that back. The issue here is that each of these denominators, each of these fractions, may not be allowed to have a denominator that is equal to 0. So there isn't any concern about the yellow fraction here because it will never be equal to 0, this 3. Same with this 6 whose denominator is 1. The only fraction we have to worry about in this particular case is the purple fraction. This x may not equal to 0. Now, the other issue with this is we do have another fraction, a 5th denominator, this whole entire structure. This whole structure is not allowed to be equal to 0 because it is the major denominator. So the way we would deal with this is we would take this denominator and set it where it was not allowed to equal to 0. Then what we could do is solve this problem. So this is kind of a problem in 2 stages. Each of these are. For example, each of these smaller fractions, smaller denominators would not be able to equal to 0, and the domain from this would say that x was not allowed to equal, the orange one would produce for you a 2, the purple one would produce for you a -1, and the green one would produce for you 0. But then we would have to take the entirety of this and set that where it was not equal to 0. That problem would look like and it looks a little harder than it actually is. All right? We'll come back to all of these, but I wanted to point out that this is the case. And again, here you would say that x was not allowed to equal to 0, and then this denominator here you would set as 1 minus 1 over x may not equal to 0. And you're going to find that, and we'll continue and solve these. All right? Let's go ahead and go on to problem 14. We'll do that one first. All right. So as I said before, this really is a problem in two parts. First, we have to reduce or simplify the fraction. We also have to state the domain. All right, so we understand the idea of stating the domain. Let's go ahead and do that part first. We know that no denominator may ever equal to 0. So in the orange fraction, the denominator is simply 1. In the green, that's the same denominator. 3 in the yellow fraction is the denominator. The only one that has a variable in it is this purple one. So we would understand that we would set x may not equal to 0. There's no more math to be done here. So I can start writing the domain down in its proper space where it says may not equal to 0. But there will be a second one. The next part is going to be, and I'm going to move in anticipation of some work that we're going to have to do, I'm going to move to, I'm just going to set this problem up here. All right. So then we also have this. We have 10 plus 4 over x may not equal to 0. This entire structure is the denominator of the larger or major fraction. So here what we would do, you have two parts on this side. My x is here. I would much rather have this is not any different than saying 2x plus 3 is equal to 0. I want the number on this side. So I'm going to minus 10 minus 10, which is going to give us 4 over x may not equal to negative 10. The difference being here in the fake problem I made up, the x is in the numerator. Here it's in the denominator. I have to move it out of the denominator by multiplying each side by x. That will cancel out. I'm not going to use that color. That will cancel out this. I didn't mean that color. There we are. Cancel out here to leave us with 4x. Sorry, 4 may not equal to negative 10x. In this case, what we would do is to divide by negative 10, divide by negative 10. We would find out that x was not allowed to equal to a negative 4 over 10, which would actually reduce to negative 2 over 5. That's going to be the next value in the domain. So we understand from previous that x is not allowed to equal to 0, but we also have this negative 2/5, which comes from the larger denominator being set not equal to 0. All right? So what we now have to do, we've got the domain stated. That is complete. This is a 5. We have to reduce the fraction. The point here is I want to get rid of or kill all minor denominators. Just get rid of them. So the way that we're going to do that, the steps are going to be to find LCD of minor. This is our job, and this is our steps. Fractions. And then multiply all minor fractions, all the small fractions, by LCD. All right? So first what I have to do is to find the LCD of all the small fractions. That would be the orange and the yellow and the green and the purple. Then I'm going to multiply all those fractions by that same denominator. So what I'm going to do, I have a lot of writing on this. I'm going to erase that so we can just see. Hold on. There, I just wanted to get rid of that box. So what's the LCD of this whole thing? The LCD for this, this yellow denominator is 3, so I'm going to put a 3 in the mix. This orange denominator is a 1, probably unnecessary to write it, but I'm going to anyway. You have another 1 here, so it's already represented, and then you have the purple, which is going to be the x. This 3 times 1 times x is going to be the LCD for this particular set of minor fractions. And what I'm going to do is I'm going to multiply each of these by the 3 and the 1 and the x. Here again, the 3 and the 1 and the x. The 3 and the 1 and the x. That's an x. Each of these smaller fractions get the same treatment. So, looking at each part individually, okay, I'm about to do some multiplication, so I'm going to take and make myself a space on the right-hand side where I'm going to write down my responses. And I'm going to use these colors again. Each zone is going to have its own answer. So my denominator is going to have two parts that are eventually going to be added together. My numerator is going to have the same kind of basic idea. These two parts are going to get subtracted from one another. Whatever I've made after I've done the multiplication. Alright? So again, this is working on the other part of reducing the fraction. If I were to go to the yellow section, I would see that there's a 3 in the denominator. That will eliminate, this 3 will eliminate with this 3 here, leaving just 1 times x times x. That will give us x squared. Notice that the denominator is gone from the yellow area. In the same fashion, in the orange, you have a denominator of 1. This will eliminate with this one here. It's kind of unnecessary to do this, but the pattern holds. Then you have 3 times 6 times 18, or times x, which gives you 18x in this section of the fraction. Again, the denominator is removed. Here, you have a 1 and a 1, leaving just 3 and x and 10, giving us 30x. Lastly, you'll have an x in this denominator part here. You'll have an x in the list of LCDs. They will eliminate with one another, leaving 4 times 3 times 1, leaving just 12. So notice what we've done. We've taken a compound fraction and reduced it to a normal rational function, or a fraction that has no fractions inside of it. The only other possible thing we could try to do is to reduce this fraction. We could take the greatest common factor of the numerator, and that's just to see if it'll actually reduce. This whole section down below is complete. So I'm going to section it off. Okay, this is our domain work. That's all domain work. Now what we're going to try to do is to simplify this. There is a greatest common factor of x, so I could write this as x times x minus 18. This denominator has a greatest common factor of 6, could give us 6 times 5x plus 2. And we see that this is not reducible, so it's finished. provided that we have a domain of 0 and -2/5. Take a moment, look at this, see if you have any questions, and we're going to go on to problem 16. All right, problem 16. Same basic idea. Again, this is a two-part job. We have to reduce or simplify the fraction, but we also have to do the domain. And that, again, is just that no denominator may equal to 0. So, just to keep the same color scheme, we have the yellow fraction, orange fraction, green fraction, and the purple fraction here. None of these denominators may equal to 0 ever. So the only ones that are in danger of equaling 0 are the orange denominator and the purple denominator. That's fairly easy to do. We simply write that x may not equal to 0. There's no more math. We know that part of our domain is just exactly that number. But we do also have this major denominator here of 1 minus 1 over x may not equal to 0. This is also in the restriction, so we have to solve this equation. What we will do is we will, again, just like before, it's similar to having 3 minus 2x equals to 0. I want the numbered part on this side, remembering to flip the sign. So I'm going to actually subtract 1 from this side, subtract 1 from this side. What we will be left with is 1 over x may not equal to -1. Right? So, we had this level of the problem, and we're going to look at now this level of the problem. I'm going to take this math and move it here. So I have 1 over x may not equal to -1. In order to resolve this, the denominator has the variable, which is not what we want. We'll multiply both sides by the x, and we will be left with the x's on this side eliminating, which will leave us with 1 may not be equal to -x. We would then divide by -1. If we divide by -1, we are then left with -1 may not equal to x. We are finished, and we find that this here is the other part of the restriction, so we include it as -1. So again, no denominator be equal to 0, so we solve those not equations, and we are finished with our domain. We ended up with two parts of the domain. We ended up with the original being that 1. This was the domain original problem that gave us the answer here, and then we also had this restriction on the left hand side. We kind of functionally had two restrictions, right? You had a restriction here and a restriction here. Technically two different restriction problems, but only one restriction altogether. Alright, so now we're left with the idea that what we need to do is to reduce the fraction. And again, we're going to find the LCD of all the small denominators. Right? So this denominator is 1, this denominator is 1. Pretty much in this case we just have 1 and the x. It's redundant to write the 1, but I'm doing it anyway. The orange fraction needs to be multiplied by 1 and x. The purple fraction needs to be multiplied by 1 and x, because there is an x here. Then you have 1 and x, and you have 1 and x here. So place for the new work. If you have the yellow, and we're going to have those same exact zones, you have a yellow zone, orange zone, purple zone, and the green zone. Sounds kind of like history or something. The denominator sections are subtracted, the numerator sections are added. So if I were to take the 1 from this denominator and eliminate with this, I'm left with just x in the yellow. Here I have an x in the denominator, which will eliminate with the x up top. This is going to leave us just 1. Here, this 1 will eliminate with this 1 here. Technically, they don't quite eliminate because 1 never really eliminates, but just a pattern. This x will eliminate with this x here, giving us just the value of 1 here. What we are left with is going to be x plus 1 over x minus 1. And this does not reduce, it does not simplify, so we are finished here, provided that we understand that x may not equal to 0 or negative 1. Negative 1. That's the domain. And this is the reduced fraction. All right? If you have any questions about this one, rewind it, pause it. Okay? We're going to go ahead and look at problem number 15. All right, here's the problem number 16. The domain is a little more complicated this time. All right? So I'm going to move this up. We only need one word domain here. The domain says that no denominator may equal to 0. So in fact we have 3 denominators. We have the orange denominator, which is going to be a result of this. We would say that x minus 2 may not equal to 0. This is from orange. We have one that is the purple, which says that x plus 1 may not equal to 0. We also have the green, where it's just x may not equal to 0. But then we have the major fraction. This is going to be 2 over x plus 1 plus 3 over x may not equal to 0. All right? So each of these, right? So here is the orange denominator, here is the green denominator, and here's the purple denominator. That's supposed to have been purple. And this is the major denominator. I'm going to put the word major on top, just so we have some understanding. This is minor, minor, minor. Okay? So each of these equations, or not equations, need to be solved. This one here is simple. It's going to be x may not equal to 2, x may not equal to negative 1, and this one is finished, x may not equal to 0. The work is really here. So, again, I use that example where you have, actually this one's going to be the same idea. What we will do is we will subtract this fraction, and we will move it to the other side. We will subtract it to the other side. So we will be left with 2 over x plus 1 may not equal, now notice what we're about to do, negative 3 over x. Negative 3 over x. Now what we're going to use is cross products. What that means is, if I were to multiply, I'm going to use a different color scheme here. If I were to use this times this, I would end up with negative 3, let me write a little bit higher. We would end up with, on this side, on the right-hand side, negative 3 x plus 1. I'm using cross products. Then what I will do is I will come the other direction, and I will use, I'm limited on my colors here. I will use this multiplied with this. So I will then have on the left-hand side x multiplied by 2. All right, so I've cross products this to create a new equation that's not fractional. So now I have 2x may not equal to, if I distribute this, negative 3x minus 1. This is looking a lot more familiar. If I were to then add 3x and add 3x, you'll end up with 5x may not equal to negative 1. If we were to divide by 5, we would find finally that x may not equal to negative 1/5. So then we would have the four different parts of the domain. We would have this, we'd have positive 2, negative 1, and this negative 1/5. Our domain would then be written as x may not equal to negative 1, 0, and the fraction negative 1/5. Now, the denominator part, or the domain part, is finished. We'll keep this all down here. The numerator part, the reduction part is a little more tricky on this particular problem. We need to find the LCD. The LCD here, I'm actually going to move this problem. I just moved it because I realized I would need more space. Bring this down here, the magic of Promethean. The LCD is going to be all of the minor denominators. So, from the orange, we are going to have x minus 2. From the purple, we are going to have x plus 1. And from the green, we are going to have x. This is the LCD that I have to use on each part of this fraction. So, what I'm going to multiply to this orange fraction is the x minus 2, the x plus 1, and the x. That's going to be the same treatment on the green. The last on the purple. So I'm going to go set up a space here, because I'm going to go ahead and multiply the orange and write the result up top. So when we are finished, we will again have, just as before, an orange space for our answer. We will have a green space for that part of the answer, and we will have a purple space for this part of the answer here. Notice that the 2 in the denominator are going to be added together. Alright? I see that the denominator of the orange fraction is x minus 2. This is going to eliminate with the x minus 2 from the LCD, leaving behind just 8 times x plus 1 times x. I see in the purple, I have an x plus 1 in the denominator, I have an x plus 1 in the LCD. These will eliminate, leaving behind just 2 times x minus 1 times x. In the green, I have an x in the denominator, and I have an x in the LCD. These will eliminate, leaving behind just 3 times x minus 2 and x plus 1. Now, there's a good bit of cleanup still going on, but you see that the fraction is no longer compound. All of the denominators, minor denominators, have been killed or eliminated. All right. This denominator needs to be simplified, simplified, and then, right? So what we will one more time do is, if I were to take multiplying this out, I would end up with 2x minus 2. All of that is going to be multiplied by x. So then I could bring and multiply here, giving us a negative 2x and a 2 2x squared. That's going to be the result on the lower left-hand side. 2x squared minus 2x. Now, here is a little different. I'm going to multiply here to get x squared. This is going to give you plus 1x. This is going to give you negative 2x. And then negative 2. These two are joining to give us x squared minus x minus 2. But there is this 3 that has to come down and multiply to everyone, giving us 3x squared minus 3x minus 6. That's going to be the second part. In the numerator, we would have 8x plus 8. This whole is going to be multiplied by the x that's sitting right here. We would multiply this, giving ourselves 8x and 8x squared. That's going to be the numerator. The only other thing to do is to combine your like terms in the denominator and see if we can reduce. We see that you have a linear term here and here. This is going to give us a combine of negative. Let me set up the fraction. Having enough space for these is sometimes the issue. That combines to give you negative 5x. The quadratic terms will give you a 5x squared. 5x squared minus 6. So your denominator is going to be 5x squared minus 5x minus 6, if I've done everything right. And the numerator is going to be 8x squared plus 8x. The idea then would be to see if this reduces. The short answer would be to put this in absence, see if there are any roots in the numerator that match the denominator, and those would cancel. We're going to call this one done for now. We would technically need to reduce, but I'm out of space and I'm out of time. See ya. If there are any questions about this, pause, rewind, and I'm going to write it that we should test for reducing. I shouldn't say test, I should say try. This one is a little bit more complicated. Practice with problems 14 and 16 instead. Thank you.